looks like I made more than I needed to. If you want to pass these back. This is just something I printed up in a hurry. A little overview of soil testing. I tried to cover it somewhat from soup to nuts. On the back of this sheet, you'll find there's an example of an A&L laboratory soil analysis. And we can go over that. Did anybody bring a soil analysis that they wanted to go over? We wrote that in the book, because if you have a soil test that you wanted to go over. We could. Okay. I was hoping I could kill most of the time with somebody else's soil test. But all right. Well, I'll go into great detail on all of this, and then let me know if I'm running over time. The first thing I thought we should probably cover is sampling procedures. One of the things you should understand about the soil is there's great variance basically everywhere you go. If you're in a field that's, say, an acre or even 1,000 square foot, you can take a soil sample, walk 10 feet, take another soil sample, send both samples to the lab under a different label, and you may come up with a totally different analysis, because there's a uniqueness in every square inch of the soil that may not be occurring everywhere else. So the best thing to do is to get a good representation of the entire area that you want to test. And the best way to do that is to take as many samples as you can of that area and mix them together. That'll give you a representation or an average of what you've got. Keep in mind that a soil test is not it's not a real accurate measurement like when you take your temperature or you have a blood test done and they count your white blood cells. It's not something that you can sit down with a scientific calculator and figure to the gram how much fertilizer you need to put down or compost or whatever else. But the best thing to do is to, if you look at that pattern that we set on there, is to just zigzag throughout your area and take as many core samples or shovel samples as you can and mix them together in a pail. Now you shouldn't ever you want to take approximately a 6 to 8 inch depth, and you want to take off the top layer, which could be anything from thatch to roots or whatever's growing in the top layer. If you're in a freshly tilled field and there isn't anything growing on the top, then you don't need to worry about it, but you should kind of flick off the top anyway. When you're sampling, you want to avoid noticeably bad or noticeably good areas, unless you want to get specific tests for those areas. Like you have a field and everything's doing great except for this one area. You want to know why. Then you can test just that area. But if you're testing a whole field and you go into some place that's noticeably good or noticeably bad, you're going to throw off the test for the whole field. Okay? If it's really, really significantly different, like you have 8-foot corn in 90% of the field and over here you've got nothing, then you might want to test that separately and just see what's going on. But you might want to look at some other things first. For instance, if the soil is, if you're in a depression, the soil is really wet, or perhaps you planted the corn and cold air got stuck in there and you frosted the seedlings or something like that. There may be some reason other than what a soil test will tell you that that's not doing so well. You should never draw frozen or wet samples. If they're so wet that you can squeeze water out of them, you'll have to dry them out somewhat. And you really should try to avoid that. You should try to draw the soil sample that you want in the consistency that you want. Because if you draw a sample and you dry it out and fluff it up and do all these things to it, you manipulate it, you change it somewhat. You change the organic matter content in it, you change what's a lot of the information that's going to come back to you, and it's not going to be as indicative of what you actually have going on in the field. Use very clean tools. This I really should stress. I had a person that used a rusty galvanized shovel one time to pick out samples, and they did a trace mineral test, and they were all off the wall. I mean, they had zinc coming out their eyeballs, and so clean. You really should be careful. Another person, they used a shovel that they used to shovel wood ash out of their wood stove. And they took a scoop of soil and they sent it in, just one scoop with all that wood ash that was stuck to the shovel. Lo and behold, they had a lot of potash, much more than they needed, and actually much more than they had. And so they fertilized according to the test, and it turns out that they didn't have enough potash, and you could see the tip burn on all the leaves from potash deficiency. So that's something that you want to be very careful of. When you're going into a sod crop with a shovel, you want to dig a hole and then cut a slice off the backside of the hole where the curve of the shovel or the spade is flat, and then just cut a slice maybe about a half an inch thick. And you can scrape off the sides and take off the top. You want to go down about 6 to 8 inches, okay? A much easier and much more accurate way of sampling is with one of these. It's called a soil core sampler or soil sampler. They're relatively inexpensive, and if you're going to sample soil once a year or even once every 2 years, it's something that will last you your whole life, and it really is easy to use. You just push it into the soil down about, well, you can push it down as far as you want, but you just take off this is open, so you just take off the top, quarter to half inch, whatever, or to inch, depends on how much root system you have in there, and then you take 5 to 7 inches there and put that in the pail, and then clean out your plug like this. You want to be careful not to drive this through your shoe because it'll throw your sample way off. Plus, aerating your foot is extremely uncomfortable. When you get all the samples drawn, all the cores drawn, you really want to mix them very, very thoroughly because, again, you're trying to get an average of what the whole field has got in it. And the only way to do that is to mix it really well. A lot of times when we make fertilizer, we find a batch or two doesn't get mixed thoroughly, and it goes through a lawn spreader or something like that, and you get all of a sudden this one area that's incredibly green or something like that. Or more accurately, a lot of times when you're analyzing fertilizer, if it's not mixed well, you could get a part of the bag that says it's much higher or much lower than the guaranteed analysis. But it was more the mixing. The nutrient was there, it just wasn't mixed enough, and the sample didn't say so. You should send in approximately a half a pound or a cup of soil. Most labs will provide you with a bag to put it in, and most bags, I didn't even bring one. I should have. Most bags will have a line on it that says fill to here, and that makes it a lot easier. And you want to send your sample in as soon as possible. One of the things that A&L tests for, and it's a test that you really should have, is organic matter. Organic matter will actually, if you let your sample sit around for a very long time. Remember, take it out of the soil, you've changed the conditions in which that soil exists. It's exposed to a lot more oxygen, and a lot of that organic matter can degrade. So you should send your sample in as soon as possible. When you get your sample back, now, this priority list that I put on here is based on the A&L test, which is on the back. This is an example on the back of this. Now, there's a lot of labs that don't offer cation exchange capacity organic matter base saturation. Matter of fact, there are some labs that all they'll tell you is they'll give you a list of nutrient. They'll tell you whether it's very low, low, medium, high, or very high, usually by a set of X's across a graph, and then they'll tell you what to do. And it's, I really stay away from labs like that, because it's sort of as if you don't have the intelligence to make a decision based on soil test information, so they don't give it to you. They just tell you what to do. And personally, I think each and every one of you knows your soil better than the lab that's testing it, and you know the conditions of it. So it's very helpful to have as much information in a test as possible. The first thing I like to look at in the A&L test is the cation exchange capacity. Now, the example here, these, if you go over, it's about the fourth column of numbers from the right. Okay, it says cation exchange capacity. Under that it says mech slash, looks like 100 grams, which is milliequivalents per 100 grams. The cation exchange capacity basically tells you the capacity of the soil to hold cations, which are positively charged ions, and they're base ions. In other words, potassium, magnesium, calcium. Hydrogen is also a cation, but hydrogen is not considered a base cation. Okay, base cations are nutrients that have the potential to exchange with hydrogen. Okay, but these CEC numbers are a little bit misleading. This is probably from a sample way out west or something. I don't know where it's from, but it's very, very rarely would you ever see CEC numbers in New England that high. Well, I've seen, well, here's one here that I brought. This one has 8.3, 12.8 on these two samples. I've probably seen it as low as 4, and I've probably seen it as high as 20 in New England. Usually what you've got, well, let me just keep going on this. The next thing I like to look at is organic matter content. Now, if you look over at the organic matter content, which is almost to the extreme left there, it's right after the lab number, that's a percentage of organic matter they found in the sample that you sent them. Now, what this tells me instantly is you get a high cation exchange capacity, low organic matter. There's only two things in the soil that hold cations, and that's clay and humus. So if there's low organic matter, the only other thing left is clay. So on those top two samples anyways, and I would say the third sample, you got a very clay soil. So you can make a lot of assumptions from that. The clay soil is very heavy. It tells you a lot of things you can and you cannot do with it.
I have a question here. The difference between organic, are you seeing organic matter and humus to be analogous because
Not equal, but relative, yes.
you can really make that direct, you can assume that directly?
Well, there's stable and unstable organic matter. But if you've drawn your samples correctly, you're going to have a pretty good indication of what you're going to have for stable humus. Because, like I said, you don't want to be driving this thing through a cow patty. That's going to give you a terrible reading on your soil sample, and it's going to show a lot of unstable organic matter. So it's all in the way you draw your sample. That's why it's so important to draw your sample correctly. Because then, when you do draw it correctly and you do get an organic matter, it gives you an indication of your stable humus content, yes. Yeah. Correct. A soil that's sandy would not only have a low CEC, it would have, I mean, not only have a low organic matter, it would have a low CEC. Okay? So that's something that, you know, you have to, sandy soil is like clay soil in that you can't really change it from anything, from what it is, but you can add to it. You can add organic matter to sand, which will help it. You can add organic matter to clay, which will help it. Yes? Organic matter content, it's not bad. 5% is what we try to shoot for. I mean, if you were a farmer and you were really trying to bring up your organic matter, 5% is what you want to aim for in New England.
I was trying to put a lawn in its place, but since soil slab is less than 1%.
Sandy?
Sand, yeah.
Yeah.
They never water it. It was like it's always ground out.
Yeah.
Really bad.
one of the things, you get on a ChemLawn program for about 7 or 10 years, and you can turn good soil into sand because you can really wipe out that organic matter through several different, well, I shouldn't say several, hundreds of different ways. So, and I don't really want to get into all of them. So. But anyway.
I take it you wouldn't recommend ChemLawn?
Only if you don't like organic matter.
Could you just briefly say how that process comes?
Well, for one thing, the excess nitrogen that you use is it throws off the carbon-nitrogen balance in the soil, and the bacteria that are trying to balance it are going to decompose humus to get that carbon. Okay. Another thing that it does is you're adding all sorts of pesticides, fungicides, insecticides, probably some fumigants. I know most of the ChemLawn applicators eventually become brain damaged. So, but actually, I'm on camera. I shouldn't say that. I take it back.
So you're removing all the air spaces, right? Is that what you're getting at?
Well, when you reduce organic matter, you start a chain reaction. What I was going to say was about the pesticides is they start killing organisms in the soil that create the chain of events that keep things going. They don't degrade thatch, so you can't change thatch into organic matter. They're unable to reproduce, which builds organic matter. You're killing a lot of fungi because they treat lawns with fungicides. And, there of the several hundred species of fungi, probably over 90% of them are beneficial. The same with insects. Of all the species of insects, probably 99% of them are neutral or beneficial. So as you start wiping out all your natural controls, then you become completely dependent on the chemical ones.
So, in other words, the organic matter is all disappearing, the air spaces are disappearing, the earthworms are dying, you have to live.
Well, earthworms can't exist without organic matter. So there's another link in the chain. It's sort of like they cannot. They live on organic matter. Without organic matter, you won't have earthworms, period, because that's what they live on. It's kind of like humus is a very important link in the food chain for soil organisms. So if you don't have that link there, it's like wiping out some important part of that food chain, and you drive to extinction in that little bioregion, all of the organisms that depend upon it.
So maybe one of the best ways to revitalize this ChemLawn, that opposed to ChemLawn, would be to, put down organic fertilizer and compost.
Compost. Where's John? There he is. You heard me say it. Yeah, compost is by far the best thing you can do to revitalize sick soil. That's what it is. It's just soil that just doesn't feel well anymore. It's on drugs. It's on an addiction. Because, well, actually the soil is not even part of it anymore. It's the plants that are on the addiction.
It's like hydroponics,
Right. You're just using the soil as a media. You're not using it as the digestive system of the plant anymore. Okay, base saturation. Base saturation I like to look at third because it's a balance of the amount of nutrient being held in the soil, the base nutrient. Okay, what they mean by base saturation is those base cations, that have the ability to exchange with hydrogen on the colloidal exchange site being clay or humus. Now those percentages are calculated by the lab, but they give you a good indication of your soil balance. You notice we haven't even looked at soil nutrient levels yet. Haven't even thought about it. So far I've just looked at how much can the soil hold, how much organic matter is there. so that it gives me a sense of the consistency of the soil. And what's the ratio of this, of one base cation to another? So I look at that, and on the back of the A&L report, and since nobody brought any other tests, I really have to, I can only refer to this. But on the back, they tell you a lot of the information you need to know to read the test. Of course, you can't read it from there. But it says right here, cation exchange capacity, and it gives you the levels, the percentage levels that they think is ideal. Okay? And what they say here is, well, okay, they say 65 to 75% calcium, 10 to 15% magnesium, and 2 to 5% potassium. Now, that's not something that you should say, you know, if you end up with 7% potassium, you go, oh my God, I get too much potassium, I'm really screwed here. That's not the case because, okay, it's 65 to 75% calcium. This is ideal ratio. Well, it says it on the back of this, because this is a copy of something, so it doesn't say it. But you can get it, if you do an AL test, it says it on the back of each copy. It also says it in their book, which you can obtain from them for $5. One of the greatest $5 you'll ever spend in your life.
I've got it. I haven't even practiced it.
Shame on you, Deborah.
I'm waiting for the winter.
This book keeps me up at night. It's so exciting. I mean, how will you ever know what happened to... Oh, I'm not going to give you this. I'm not going to give it away. Okay. The ideals. Okay. Starting from on the test here, we got potassium is the first one, 2 to 5%. Magnesium, 10 to 15%. Calcium, 65 to 75%. And hydrogen, well, if you've got everything else right, hydrogen will be right where it's supposed to be. There are other cations, trace mineral cations, but there's also aluminum. Aluminum is considered a non-exchangeable cation if your pH is within normal range.
But you can't do that.
Well,
You're working with 4%, 4 pH, and then you have to consider the...
right. Well, we'll get into pH, but really, I don't really consider aluminum. Vermont is big on aluminum, and they, instead of giving you buffer pH, they give you a level of aluminum. And, you know, they're so relative to each other that I don't really understand the need for speaking of pH in terms of aluminum. But they like to do that, so. Anyway, where were we? We were talking about the base saturation. Okay. That gives you a balance. Now, if your base saturation is balanced, and you know what your cation exchange capacity is, and you know what your organic matter is, then you're going to go over to the nutrient levels, which I believe is the next on the list, and you're going to see that they all say between medium and very high, you know. They're going to all be good. But those levels are only relative to what the soil can hold. Now, if you have a very, very low CEC, such as you would have on sand, it may say very high potassium or very high calcium, but it may not nearly be enough to sustain the growth of a crop. And that is because the soil can't hold any more than that. So,
Is it also that it's bound up?
no,
No.
it can't hold it. And
What if
sandy,
there's something inside of it? And it's there.
well, you're not measuring that.
Oh, all right.
You're only measuring exchangeable cations. Okay, these are cations in the soil that are already in soil solution attached to soil colloids. Okay. So yeah, these are measuring available. They don't measure. The only thing that they measure in reserve is phosphate, because it's not a cation, it's an anion. Okay, and phosphorus is one of those things you got to have. But getting back to the cations, if you have a very, very low CEC, your nutrient levels may say high or very high, but it may be totally inadequate to grow a crop, which is why I always look at the CEC and the base saturation before I look at the nutrient levels. If you find that your CEC is very high, you may have, to give you an example, you may have, let's say, 900 parts per million calcium with a CEC of, let me look this up so I can be completely accurate in my wonderful book here. In sand, where you have a CEC of, say, 1, parts per million of calcium, okay, let me put it this way. Calcium at 65 to 75% and a CEC of 4 is 520, okay? So if you have a CEC of 4 and your calcium level is 520 parts per million, your test is going to say your calcium is high. But if your CEC jumps up to 14, to have that same high, you have to have 1,820 parts per million. So for the same amount of calcium in a different soil, your CEC is going to say very low. But it's all relative to what the soil can hold. If you have sandy soil, your biggest problem is going to be increasing that CEC. And those are the first two things you looked at. You looked at the CEC and you looked at the organic matter. You don't want to add clay to soil. It's not practical. But organic matter is in the form of compost. Manure is not practical to build organic matter. It's very unstable, and it just disintegrates quite a bit of your organic matter. Probably 70% of it you lose. But compost, that 70% is already gone, so what you get is what you get. It's much more stable. The other way to build organic matter is green manure. And I keep getting back into this. Don't confuse green manure with cover crops. Cover crops are not green manure. Cover crops are put on the soil between plantings, usually a harvest in the fall and a planting in the spring, to hold the soil, to absorb nutrient that may be free, and you want to lock it up into the cover crop, and to control weed, to suppress weed. And cover crops work great for that, but they do not build organic matter. Green manure is something that has to sit in the soil for at least 12 months to build organic matter. Keep in mind, 1% organic matter in an acre furrow slice is 20,000 pounds of stable organic matter, 10 tons. So it's not easy to build organic matter, but green manure does it fairly well. A 2-year crop of a flourishing clover or alfalfa or something like that, something that has a really significant root system, would probably build organic matter between 1% and 1.5%. Yeah. You might actually get, if you get a real good crop, you might get 2%. But that's 20 tons. That's a lot of organic matter. But most of your organic matter is coming from your roots, not your top growth. I see all these people growing buckwheat, and they go, oh, God, look at all this organic matter. Well, buckwheat's 80% water up top, and you till it in, and after they've oxidized organic matter from rototilling it over and over again, they look at a test and go, my organic matter is less than when I started. I've gone through 3 crops of buckwheat, and I got nothing. I've had some people who say, well, I disagree with that. I've done my tests and it's worked out. Well, fine. If it does work out for you, you're doing something I don't know about, and probably you don't know about either. But well, legumes will create nitrogen. There are some legumes like clover that create really dense root systems. Okay? Sometimes it's better to have a mix. If nature teaches you one thing, is to diversify your investments. If you go into the woods and just pace off a 10-foot square area, you could probably find over 100 different species of plants. Nature diversifies just in case conditions aren't good for a few of those species. So the best idea is to put in, a mixture of different seeds. Some grasses, some legumes, different kinds of legumes. Also, there's a lot of acid-tolerant legumes that you can use that will build organic matter because, like some of your white clovers that really do give you a great they're not very acid tolerant. So if you have a low pH, you're just wasting your money on seed. Okay. Here's a book called Green Manuring, Principles in Practice. And it was written by Otto Schmid and Ruby Clay. They're out of the Research Institute for Biological Husbandry in Switzerland. But it was translated by Will Brinton of the Woods End Agricultural Institute. And you can contact him or somebody there to get this book. And it goes through all of the different ones. Harry Vetch is a... Can I give you what? I got 2 addresses here because I got 2 different books from them. Oh, well, now you've got me. I got to look it up. There's a lot of tables in here, and this might take longer than... Wait a minute. Yeah, it's in Maine. There's a bunch of tables in here. I seem to recall seeing the vetch as being somewhat acid tolerant in one of these tables, but I may be wrong. Chances are I'm not. I've got a good memory. Okay, one address for them is Orchard Hill Road, Temple, Maine, 04984. The other address for them is, drum roll please, RFD1 Box 4050, Mount Vernon, Maine, 04352. 04352. Okay, base saturation is a calculated figure. And what it says is that the cation exchange capacity can hold, of the soil, says the soil can hold this much nutrient. You got either a little bucket or you got a big bucket. Look at it as a bucket, okay? And the CEC is just a measurement that tells you the size of the bucket, okay? In that bucket, it's saying that of all the exchangeable base cations, okay, and they're measuring potassium, magnesium, and calcium, they're saying that ideally you want 2 to 5% of those exchangeable base cations in that bucket to be potassium, okay? If you look at the test, it says 1.5%. So this guy's got a potash problem. If you just kind of zip your eyes over to the potash column, you'll see it's low, okay? Now, I'll just point something out to you. 167 parts per million in a soil with a CEC that's down around 10, well, not 10, say about 5, would be off the chart, okay? At 2 to 5%, high is 108, okay? I'm getting it from this book. This book is called the A&L Agronomy Handbook. Yep. I can tell you, I can give you their phone number, or I can give you their address, or I can give you both. Hey, there you go. Actually, but this is Omaha, Nebraska. You could probably get it from them, but Richmond, Virginia is closer. And Richmond, Virginia is 804-743-9401. Or you can write to them at 7621 White Pine, one word, Road, Richmond, Virginia, 23237. Those are the guys that I deal with, and they're very, very nice. And it's a great book for $5. You'll never spend a better $5 in your life. You know, can't get into the Big Apple Circus for $5. Okay. Any more questions on base saturation? Okay. Okay. Well, whatever the measurement is, I've never seen a cation exchange capacity measurement of 0, where the soil can't hold anything. I've never seen that. Probably if I took a soil sample from a beach on Maine coast, I would probably get that, or I'd get pretty close to it. But generally speaking, if there's anything growing anywhere, the soil has to be able to hold some nutrient, or you just can't, even weeds wouldn't grow. So there has to be some capacity. And what that capacity measurement is, the CEC, it just tells you how much that soil can hold. And the base saturation is the percentage of each of those base cations that's in that bucket that I keep referring to. So if it says in a sandy soil that you have very high potassium but very low calcium, in other words, it's saying your potassium is 20% and your calcium is 10%. Well, you know your calcium should be around 65%. So you've got, not only have you got low nutrient levels because of the cation exchange capacity of the soil, but you also have a significant imbalance. Something that with a low CEC is easy to deal with because you don't have to add much to bring it up. With a high CEC, you've got a huge bucket to fill. Low CEC, you just got a little cup. Okay? Okay, getting on to the nutrient levels. The nutrient levels are what I look at next. And basically, in the NL test, they tell you parts per million. Now, there is a way to translate that into pounds per acre. On the back, which you don't have, it tells you how you translate it. For, no, actually, right on the front it does. Yeah, it's on the bottom, I'm sorry. Okay, and it does tell you how to translate it. Okay, you can get to pounds per acre. Potassium, okay, it shows the 5 stars, you multiply by 2.4 to convert to pounds per acre. And phosphorus is 4.6, okay? Magnesium and calcium are, you multiply by 2, I believe, okay? The reason is because in a acre furrow slice is approximately 2 million pounds of topsoil. So if you have parts per million, then you multiply by 2, and you get pounds per acre.
What did they assume? 6 inches? 12?
6, 7 inches, yeah. Yeah, that's what they assume. Now, those nutrient levels, again, that's one of the last things I look at because I wanted to get a picture of the soil first. I want to see what kind of nutrient holding capacity it has. I wanted to see what kind of organic matter it has, which tells me also how healthy it is. Because if it's very low organic matter, there's potential for a lot more problems. Because low organic matter is going to be analogous to low populations of soil microorganisms. They have to have organic matter to live. I should say soil organisms. Earthworms are just as important, and they are not microorganisms. When you get to the point where you've looked at all those things and then you're at your nutrient level, you can actually look at the parts per million, or translate it into pounds per acre, and compare that to what your nutrient needs are going to be. Now, if you're growing a crop, there are tables in a lot of different books. There's also tables in this book that tells you what your crop's going to need. So you could have levels across the board that say very high, very high, very high, very high, but you don't have nearly enough there to grow a decent crop because your cation exchange capacity is too low. You can't hold enough to grow a decent crop, which means in the interim, while you're trying to build that soil organic matter, which will build the holding capacity of the soil, you're going to have to spoon feed nutrients or get very slow release organic fertilizer. Compost is going to kill 2 birds with 1 stone. It's going to give you a concentration of slow release nutrient. It's also going to give you ability to build soil organic matter, which is going to build populations of organisms, which is going to build more organic matter. It's as close to a perpetual motion machine as you can get. And that's in the soil. If you can stimulate that soil machine, it can go on and on and on and build itself.
What is the effect of like ammonium nitrate on
Well, it's pretty nasty stuff, actually. Ever stuck your nose in a bottle of ammonia? Well, the microbes don't like it either. It acidifies the soil. It creates a significant imbalance of the carbon-nitrogen ratio. It also feeds directly the plants instead of going through the soil digestive system. If any of you have ever been in the hospital for medium to long stay and they put you on IV, what they're doing is the same thing as chemical fertilization of plants. They're feeding you direct. They're bypassing your digestive system. When they do that for a long period of time, your digestive system will shut down. It will cease to operate because it doesn't need to, and there's nothing for it to do. It's even more crucial in the soil because you're dealing with living organisms that rely on that raw material for their life. They can't even exist, and they die. There's no unemployment in the soil. So when you get to a situation where you're bypassing that digestive system, you start creating a chain of events that's going to slow down and eventually stop that perpetual motion machine. And ammonium nitrate is one of those things that will start to do that. Chilean nitrate is not acidifying. It's actually neutralizing. So Chilean nitrate, you can feed nitrogen directly to a plant with Chilean nitrate, and you can bypass that mineralization of nitrogen. So if you use Chilean nitrate, you should use it judiciously. The standards in most of the certification groups, except Massachusetts, allows 30 pounds actual N per acre per year, which is, in my estimation, using it judiciously. Some certifications don't allow it at all, certification groups. So, of all the soluble nitrogens, Chilean nitrate it's not innocuous. Well, nothing's innocuous if you overdo it. You heard about the rat who was injected with whole wheat bread? It died. You know, it's all relative. So, moving on here.
Well, it's like if you eat too much of it.
Grand Scientific American.
If you have too much vitamin
That was a National Lampoon.
if you have too much vitamin A, you can make yourself ill.
Sure.
Whereas if you have a small amount, it's controlled.
On my camera, I can't comment on that. Okay. So your nutrient levels really are important in terms of what you need out of the soil. Okay? So you already know what the soil can hold. You know where your organic matter is at, whether you have to improve that or not. You know what the balance of your nutrient is. And if it's imbalanced, you can correct that. And you know if you've got enough nutrients to sustain a crop of whatever it is you're trying to produce. If you're in landscape or lawn care, you're in a situation, in a better situation than most people who are trying to produce food, because you don't have to remove nutrient from the soil. You can recycle it. You're in a better position to recycle nutrients. Leave the grass clippings, mulch the leaves, turn them into compost. You know, whatever you're doing, you are in a better position to leave the soil fallow than if you're trying to raise vegetables or hay or something like that. Because each time you remove a crop, you remove nutrients, which has to be replaced.
What about raising them?
Yeah, people do that. In lawns, you can get almost 2 pounds of nitrogen per 1,000 square feet from the grass clippings. So it seems a real shame to rake them all up. Mulching mowers are a real good idea, and I think fairly soon you're going to see them available to the commercial lawn care companies, mulching mowers. I think they have attachments now that that will mulch. But that's really the best idea. The trick to lawns is if you mow them high and often, you never have clippings you can see anyway. Right. But you never know, if you get enough rain and you just don't get back in time, and lo and behold, you're cutting off more than you should, and there's a lot of clumps and stuff, and the customer comes running at you. You're not going to leave that there, are you? And you say, no, I guess I'm not. Okay, any questions on nutrient levels? Good. I'm going to move on to pH. pH means power of hydrogen. The pH range, which is 0 to 14, 7 being neutral, is not analogous to how much hydrogen is in there. It's just a range. I'm not sure how they came up with that range. But 0, of course, being the most acidic, 14 being the most basic or most alkaline. The ideal growing range, depending on organic matter, and I say that carefully, is between about 6 and 7. 6.5 is really ideal. If you have a lot of organic matter, like in organic soils, there's not too many organic soils in New England, but there are some. I've seen peat soils in Massachusetts, actually. Yeah, muck soils, what they call them. They have a tremendous amount of organic matter, and the amount, when you get into real high organic matter, you get into real high CEC. When you have the ability to hold so much nutrient that even though your saturation of hydrogen is a little higher than it should be, there's plenty of base nutrient, plenty of potassium and calcium and magnesium to sustain growth. So you'll see in potting mixes, for instance, which are all peat moss based, usually their pH is going to be around 5.5 to 6, which in normal soil you'd say, no, that's too low, I got to sweeten it up. But in high organic matter soils, that's okay. And if you look at, well, I don't have anything you can look at, but in the back of this soil test, if you ever do an AL test, they even tell you that with organic soil, so they have mineral soil and organic soil, and they tell you the buffer pH, which I'll explain later, if the buffer pH is 6.7, they want 1 ton of lime to the acre, but 0 if it's organic soil. As a matter of fact, you can go all the way down to 6.4 or 6.3 before they say put any lime down on an organic soil. Okay, that's the difference. But you really shouldn't concern yourself too much with that because there aren't too many organic soils in New England, mostly mineral soils.
Not only that, it's economically you're already down there.
Well, before there was a law that you couldn't drain wetlands, there were people that drained bogs. But actually, if you look at the natural evolution of a muck soil, for instance, you got a river 1,000 years ago. Beavers come in, dam it up, all the sediment comes in and creates this huge field of muck. And the river, eventually the beavers leave and the brook runs, either finds a way around or it just trickles through a center thing. Well, you've got this big field on either side of it that's high organic matter soil, muck soil. And it just naturally occurred that way. And it took hundreds of years for it to do that, but there it is. And you don't have, it's not like somebody drained it, it's just a natural occurrence. You can find some muck soils around Mount St. Helens now. But, okay, pH, the power of hydrogen, is the power of hydrogen that is attached to the colloidal exchange site, the cation exchange capacity of the soil. There's just a certain amount of cation nutrient that the soil can hold. Hydrogen is one of those, whether you want to call it nutrient or not, it is one of those ions that sticks onto the soil. The ability for base cations such as calcium, magnesium, and potassium to displace them depends on its abundance in the soil. Okay? the way they measure, the way A&L measures, is they have pH and they have buffer pH. The pH is they basically take equal amounts of distilled water and the soil, and they measure the amount of hydrogen in the solution that they have. And that tells them one thing. It tells them if you should lime or not. Then if it says, yes, you should lime, let's say the pH comes out around 5, then they run a buffer pH test. And that is with what they call an SMP solution. Don't ask me what that means. But if I looked it up in here, I'm sure I could find it. But the SMP solution measures the amount of hydrogen, not only in soil solution, but that is attached to the soil colloid. Where you really get into the need for buffer pH is when you get into the different levels of cation exchange capacity. A sandy soil, which doesn't hold a lot of hydrogen, would probably have a fairly accurate pH just from the water test. But a clay soil or an organic or a soil with a fair amount of organic matter is holding on to that hydrogen. It's not letting it go into the water solution. So the water pH test can't measure it. The buffer pH test can. Oftentimes you'll see that your buffer pH is higher than your water pH.
When you have one of these little soil test kits,
Mhm.
like say from Mars, is that the water?
I'm not familiar with those kits, but
They have a
what you have to find out is what kind of solution are they using?
We put water in and
Most of them are water pH. Okay, most of them are water pH. Now, a lot of labs you might come back with a test that says salt pH. I don't think any labs really test salt pH anymore, but they probably have some old forms that still say salt pH. But salt pH is basing the test on the assumption that you're going to have high salt index fertilizers either existing there or going to be used. And it's basically liming in anticipation of the acidity caused by them. But again, salt pH is something very, very few labs, if any, that I know of ever use. So if you see salt pH on a test, chances are it's just an old analysis form, and they're using a water pH. Okay.
So can you explain the buffer pH again?
Okay, the buffer pH is, cations have a positive charge, and they, of course, attach themselves to anions, or anionic colloids, with a negative charge. We call it electronegative forces, or electronegative power, or whatever. Those electronegative forces, if they're strong, if there's a lot of them in, say, a clay soil or a soil with high organic matter, it will hold hydrogen that will not migrate into that water solution. So although the pH test says, yeah, you've got enough hydrogen here to warrant liming, it doesn't say exactly how much lime you're going to need, because it's not accounting for all of that hydrogen that's still attached to the soil colloids. Okay. When you get into the buffer pH, they use a solution which will actually, in a sense, measure. It's kind of technical actually how it does it, but in a sense it measures the amount of hydrogen that is still attached to that cation exchange site. So it gives you a more accurate figure by which to line. Well, you should always use, if you're offered a buffer pH by a lab, you should always use that to line. The lab will not offer you a buffer pH if your soil pH is high. If you look at this test here, I don't know if it's on this one. No, okay, but if you look at this test here, and I'll pass this around, you can look at it. The soil pH is 7.1. So they said, we're not even going to run the buffer test. They're just saying, you don't need lime, period. Okay? Would I question it?
based on the buffer pH, or is that plenty alkaline enough so that,
Yeah, I would say that's more than alkaline. Unless you need more alkaline soil than that, I don't, I would, well, you send your soil to a lab that you trust to get that information. So A&L, I use A&L labs because they're very fast, they're very consistent, and they're a private business. In other words, they have a lot to gain or lose by their reputation. I tend to shy away from some of the universities. Some are better than others because they're basically state endowed, and if they hand you a bogus test, what are you going to do? I mean, it's not going to ruin their reputation to the point where I don't know whether they really care that much. I don't know. I mean, some soil labs are, I'm sure, much more conscientious than others. But a lot of times you'll have students, working in the lab, and let's say they mixed some of their reagents incorrectly. They didn't go by the book, or they made a mistake, or whatever.
so if your soil test comes back and the pH is low, then you see the buffer pH is higher, then you might not need soil.
Right. There are plenty of instances that I've seen where the soil pH shows something that indicates liming, but the buffer says, no, you don't need it.
So in sample 3, that's the soil pH 5.7 and water pH 6.7.
Well, I'd have to look that up, and somebody else get that thing. Who's got it? You want to look on the back there? See what it says under liming 6.7?
The other thing you should know in the fact saying that book is line is not the only thing that
This is true. Well, anything that will displace hydrogen will influence pH, which includes calcium, magnesium, potassium.
you might find that it's only one and a half.
Yeah. That's where you go back to your numbers. Oh, what does it say for liming buffer pH 6.7? Okay, what does it say for 5.7?
7.
Okay. So that's a big difference. 5.7 says you should use 7 tons of lime, and the 6.7 buffer says use 1.5 tons. Okay.
When you give line recommendations, is it assuming what kind of limestone?
Well, I'd like to get back to what John said. Calcium is not the only thing that influences pH. Any cation that can displace hydrogen will influence pH. So when you see your pH, you have to look at your nutrient levels. You got to go back a step and look at your nutrient levels. If it seems to you, even according to crop needs, that you have more than enough calcium and it's excessively high already, then that's probably not the problem. It may be that you need magnesium, or it may be that you need potassium, or both. Okay? And that might be what's throwing off your pH. You have to look at your nutrient levels. If it says that you're low in both calcium and magnesium, then dolomitic lime is appropriate. If you're high in magnesium but low in calcium, you don't want to use dolomitic lime.
My question was wondering when you give recommendations for lime on each test, which type of limestone are they?
Between what choices? Dolomite and calcite?
Yeah.
It depends on your magnesium level. If you have high magnesium level, you don't want to use dolomite. If you have low magnesium and low calcium, then you'll be using dolomite. Okay? And we went through that a little bit on these deficiency scenarios that are right in here. But getting back to pH, once you've determined that you do need to displace some hydrogen, and John's correct, I shouldn't say lime. You need to displace some hydrogen. You've got to look at what you need. And it's pretty simple. If you look at the levels of potassium, magnesium, and calcium, you can see in an instant what you're going to need. There's one thing I should talk about here that I haven't really touched upon, and that's phosphorus. Phosphorus, they give you two measurements, what they call weak Bray and strong Bray. That is what they consider to be available and reserved phosphorus. Weak Bray being available and the strong Bray being reserved. Phosphorus is one of those things that you can add to the soil and it will stay there. It doesn't migrate in the soil. But it's also one of those things, if you add in a highly available form, it can lock up with other nutrients. Highly reactive. It's anionic, so it has an electronegative force, and it will bind up other cation nutrients. So it's important when you add phosphorus to add it in the right way. Sometimes you need a bunch of available phosphorus just to get a crop that's going to feed you over the winter. But a lot of times you just need to build those levels over time, in which case rock phosphate's your best bet. Some of the deficiency scenarios that I put on this sheet were just a few that I see fairly often.
So if you want soluble, or you want potassium quickly, phosphorus quickly, what would you need?
Well, that's a tough one, to tell you the truth. There's not too much in the organic field that's relatively available. There is a precipitated bone meal that's accepted by all certification groups that has a very high available phosphate, but it's very dusty. So on a large scale, it's very difficult to use. There's some companies that are looking into pelletizing it, but that makes it even much more expensive. Bone meal already is very expensive. Soap, black rock, but still we're dealing with tricalcium phosphates. All of the rock phosphates are tricalcium phosphates, and they're fairly slowly available. If you need 100 pounds of phosphate now, then you're going to have to put an incredible amount of black rock phosphate down to get the 3 to 5% available. Most of the fish emulsions, there's one squano secret that actually mills the bones, and you can get foliar phosphorus from it. But most fish emulsions, the phosphorus comes from phosphoric acid, which is not acceptable. Soap phosphate, which is increasingly harder to get, is also, which is a calcined rock phosphate, is also accepted in most certification committees, and that is relatively available. Okay. Well, that depends. Ideal levels for phosphorus are based on, let's see now. Oops, I'm not even looking at a test anymore. They don't vary as much as the cations because they're not dependent upon the cation exchange capacity of the soil. Phosphorus levels, you need about, on hay crops, you need about 15 pounds per ton of hay that you remove, which is about 75 pounds a year for a good hay crop. Okay, and that's generally between 50 and 100 pounds per year is what you're going to remove out of a crop. Some crops are going to take more out of the soil than others. Obviously, some crops that like phosphorus better than others. But in this book here, and I'll give you phosphorus, page 23, they give you a table of extractable phosphorus, and it really doesn't vary according to anything other than they're just saying the P1 medium levels are going to be 18 to 26 parts per million, which is the same as 81 to 120 pounds per acre. Okay? They also have, that's P2O5. Then they have some other measurements in here too, but P2O5 is what it's measured on the bag, and high levels would be 27 to 39 or 121 to 180 pounds per acre.
What about potassium? I thought that was pretty bound up in the soil also, not bound to move that much the same.
I think what you're thinking to is the 27,000 pounds of potassium in every acre of soil on average in the world. There is a lot of it, but it's mostly unavailable. But once you start that perpetual machine going, you start stimulating all those bacteria and roots and everything else that can dissolve bound up mineral like that, you can start tapping the bound up potassium stores. One of the things about green sand that never has been proven in a lab or anything, you take green sand into a lab and they'll say this stuff is worthless. Take it to a landfill. But I believe it has a synergistic effect in the soil. You put it down and it stimulates those solubilizing bacteria that when they reproduce, they start working on all the other potassium that's already there. Because green sand does stimulate those bacteria.
What do you think about the recommendation if you have to keep things simple, only taking a pH test to consider how to, correct the amount of fertilizer that will be necessary or stored, and then just consider that you have to continually build up all the other nutrients by adding compost and a balanced fertilizer.
Yeah. Well, the only thing I can say about that is if you're out hunting and you're really hungry and you see an elk or whatever that you need to have to feed your family, you're not going to shoot from the hip. You're going to aim carefully. If you're just out hunting for the fun of it, you might shoot from the hip. So it depends on how much risk you want to take. If your chances are you're going to be right on. If you do a pH test and it says you're low, you lime it, and chances are you're going to be okay. But on that off chance that you might need magnesium or potassium or something else that's affecting the pH.
If you're putting on a balanced organic fertilizer, you
Right, but a balanced organic fertilizer usually is going to address crop needs based on a balance that's already there. It's not going to correct a deficiency. It's not meant to. Okay? So if you have a deficiency of some kind, the level of that deficiency is going to control the level of all your production, no matter what it is. If you need 1 part per million boron in the soil and you only have a half, the crop will only grow to that level. It's like, and a lot of you have probably seen it, if you have a rain barrel and with a broken slat, the barrel will only fill to the level of that break. It can't go any higher.
So how often in suburban lawns do you find that you have those things?
Probably not too often.
You can have contaminated soil sometimes.
Mm-hmm.
I don't know.
Probably not too often. Usually, when you're in land care, either lawn or landscaping, usually you can shoot from the hip and be pretty safe. And you have to wait until you have a significant problem that your shot from the hip is missing. Then you have to go into depth. You have to research it more. You have to take that leaf tissue analysis, or you have to do a soil test and find out what is causing this problem. You know.
So you're saying farming should be much more conscious.
In farming, you've got too much riding on that acre. Okay? When you're about to go out and plant a crop, and there's $8,000 to $15,000 worth of gross revenue coming off that acre, you can't afford to wait till halfway through the season to find out you got a problem. So it's a much different story. In that instance, you really have to take careful aim. Oh, relatively inexpensive. That first soil test that you see on the top, is called Soil Test 1A, and I believe their price per sample is $7.35, plus to get all that information per sample. Okay, each one of those lines is a sample. Right. Okay, $7.35 plus postage. It depends on how much soil you mail them. But it's really not bad. I send my stuff into them. I go into the post office. She goes, "How do you want this to go?" And I go, "Cheap, cheap." And they send it parcel post, 4th class, or whatever, and I still get my analysis back in 10 days. Well, it's sealed in a bag. You're not dealing with significant oxidation. Okay. So. Yeah, the more samples you send, actually, the cheaper it gets because per sample. Because the post office, if you go up a pound, it doesn't go up. It doesn't double the amount. It goes up like 15 cents or something like that. No. And there's very few labs that can accurately do that. There's a few labs, they charge an awful lot for their tests, but they give you your money's worth because they'll give you a complete scenario of your soil, a complete profile of it, and they'll do gas chromatographs of your humus, and they'll analyze that, and they really go from soup to nuts in your soil, and they give you a real good analysis of it and what you should do for it. So you may pay $30 for a sample, but you get your money's worth in information. Because you're paying for a consultation on top of that. With A&L, basically all you're getting is analysis.
Julie said in her basic on organic farming that A&L will make suggestions for organic amendments if you specifically ask them in a workshop on farming.
Well, all I can say is I know the people at A&L, at least the one in Richmond, and they're very, very intelligent people, but the 99.99% of their recommendations are based on chemical application. I don't personally feel they're equipped to make organic recommendations. What you will probably get from them in organic recommendations is a generic recommendation saying use bone meal or rock phosphate for phosphorus, and they may not even tell you how much because I don't know if they know. Well, yeah, Paul Sachs gives it. I end up giving a lot of recommendations. There are a lot of people that have been involved in organics for a long time you can get recommendations from. One of the things that you can do with their tests, especially if you have this $5 book, is you can figure it out for yourself. And when you become less dependent on somebody else to tell you what to do, you're all the better for it.
But this is too bad because the general consumer sends their soil to mass soil lab, and it comes back and tells us to use a certain amount of urea or whatever.
Yeah. Well, actually, most of the university labs will make organic recommendations. You have to ask them. And what they send you is pretty much a formula that tells you what nutrients you can get. But they have a liability factor, and they have a hard time actually saying use, 10.4 pounds blood meal plus this, that, and the other thing. So they give you a sort of a blanket recommendation. It tells you about different things that you can use to address different deficiencies in your soil. And that's basically all you need because organics is not as exacting as chemicals, because in chemicals you're just feeding the plant. You're not going through that digestive system in the soil. In organics, when you put organic material down, the soil is going to regulate the availability of certain things, and it's going to balance itself out. Compost is a perfect example. You can take a dozen different ingredients, all of which have certain imbalances. That maybe one has too much nitrogen, one has too much phosphorus, one has too much carbon. But once that compost is finished, it's all balanced out. That's what the microbes do for you. They balance it all out. How much time have I got left? Okay. All right, we're doing good here. I put down a list of some deficiency scenarios with remedies. And these are some that I just I come up with from time to time, and I just put down a generic recommendation. If you have low potash and high magnesium, you don't want to use sulfamag. You can use sulfate of potash if you need a lot of it immediately. Muriate of potash is prohibited by most certification groups. It's potassium chloride, very high salt index, very acidifying. It is natural, though, so anybody tells you different, they're wrong. It's as natural as sulfate of potash. Green sand is a very slow-release potassium builder. It's an excellent soil conditioner. If you don't need a lot of potash right away, green sand's an excellent thing to put down. Low potash, low magnesium, sulfate of potash, magnesium, or sulfamag, it's also called K-mag, is an excellent thing to put down. One thing I'd like to mention to you in these scenarios, this is not the only way to do this, okay? It's just one of the ways that you can treat these deficiencies. There's probably other ways. Okay, I could think of a few. I could go through a lot of different scenarios. But low calcium, low phosphorus. Black rock phosphate or any of the rock phosphates are calcium phosphates, so you're going to get both calcium and phosphate out of it. I'd like to skip one for a second and go to high calcium, low phosphorus. And I put tough situation if you're organic. It is a tough situation if you're organic because calcium and phosphorus come together when you're using natural sources of phosphorus. Even bone meal is calcium phosphate. So what do you do if you don't need calcium but you do need phosphorus? You need something that's going to acidify. And the only thing you can use is superphosphate or triple superphosphate, and those are prohibited. So you got a problem. If you're organic and you have high calcium and low phosphorus, especially to the point where your calcium is excessive. I've seen a few cases of it. Yeah. Well, a lot of times that happens where people lime indiscriminately. Just go out and lime. And or another place you might find it is where is by the barn where the manure is just out there. Well, I don't feel like taking it out. It's icing out there. So you throw it out the barn window. But manure it's got some phosphorus in it, but it's not balanced. It's got a lot of calcium in it. Very, very alkaline manure, up around 8.5 sometimes. Well, there's some things you can do. The best thing you can do, you have to look overall at the test, because if you look at the test and it says, well, you got high calcium, it's excessively high, and low phosphorus, but it also says you have low organic matter, or or something like that. You have to look at the whole picture. One of the things that really irks me is when you get a test that says only that you have high calcium and low organic and low phosphorus. It doesn't tell you anything about your organic matter. It doesn't tell you base saturation. It doesn't tell you anything, and you really have to shoot from the hip, even with the test. You have no choice. There are some things you can do. Basically, you have to try to acidify the soil at the same time that you're increasing the phosphorus. You have to lower the power of that calcium. Yeah, something like that. Fine oak leaves, cottonseed meal will acidify. Sulfur will acidify. Yeah. John, what happens to the pH of oak leaves after they compost? I assumed you did. Okay, I'm going to jump back to the low calcium, high phosphorus lime is the easiest thing. Compost is something that I like to recommend. especially if you have low organic matter. Compost is something that really does dress up the soil. It improves so many different things. Low calcium, low magnesium, dolomitic lime. That has both calcium and magnesium in it. Low calcium, high magnesium, calcitic lime. Don't use dolomite. You can throw a lot of things off with your magnesium too high.
Isn't it true that most agricultural limestone, like blue limestone, has enough magnesium in it that you don't
It should say so.
It does though. It says right on the label.
Right. If it's
And
then
oxide and-
you have to look at the label. If you don't want magnesium, you don't buy. Some companies, they have a mine that only mines dolomite, so all they offer is dolomite, and Lee lime might be that. And if it says on the label, all we can offer you is this with magnesium, then you want to look someplace else. You want to look for something that's just calcitic lime. If you don't need.
Some people just look for a dolomitic lime. Sometimes not labeled like that, so it's hard to say. Just to look on the label to see what the compound is on. It's not going to say dolomitic limestone from.
Well, you might be right, and I always recommend to anyone that they read the label of anything. That's I don't usually buy anything without reading the label unless I've already read it before, and then sometimes I'll just check see if it's changed. But no, that's really important. One of the things you should pay attention to on any product for agriculture is the label. If it's fertilizer or lime, you should pay attention to the guaranteed analysis. If it's pesticides that you're going to use, even if they're botanical pesticides, you've got to pay attention to the label. It is against the law with pesticides to use it, to vary it from the label directions. If you use more than what the label says, you can actually be arrested. Or if you use it on something that the label says it's not for, you can be arrested. And there was a guy in Vermont who got arrested. He used sabadilla dust on strawberries to control tarnished plant bugs, and he got arrested. Yeah.
I think
Joey Klein.
some people will fly 2,4-D on the lawn of their dog right there. And I've seen it.
Depends on how much you like your dog, I mean, if you have a dog that barks all night. Anyway, low potassium, magnesium, and calcium. All your cations are low. Wood ash has a lot of the three major cations. Compost will bring up your cation exchange capacity and your cation levels. And dolomite will address the calcium and magnesium. I'm not saying use all of those. Those are three choices. If you can use a little of each, that would be great. Low organic matter. We talked about this a little bit before. Compost and or green manures will build your organic matter better than anything. No, the best way to raise a green manure crop is so that you can get something out of the land is to pasture it. If you can integrate the whole system with animals, you're better off. They mow it for you, and they have a little compost system inside, and they squirt out compost at the back end. It's a great system. If you can't do that, then yeah, you have to mow it at least at the end of the year so that you don't have this mat of top growth that's keeping it from coming up again. Okay. But yeah, if you just mow it, although clover you don't want to mow like you mow a lawn. You'd want to let it get up. As a matter of fact, if you're going to let it grow for 2 years, you want to let it flower. Okay. Then you could hack it down. I usually recommend hacking it down at the end of the year. If you don't have anything that's going to chop it up into fine things, then you can compost it. And spread it back on the plot or the field. It depends on what is practical and what is impractical. If you're dealing with a garden, you have a lot more variability. You can do a lot more things. If you're dealing with a 20-acre hayfield that you're trying to build organic matter on, or a cornfield is a better example. A good farmer might put his cornfield into clover or alfalfa or both for 2 years. He'll hay the clover, and then when he gets done after 2 years, he'll plow it down, and he won't need any fertilizer or weed control for that corn for the first year. Second year, he'll probably use some starter fertilizer and maybe some manure. And then he'll go back into sod crop again. Yeah, he's building. Yeah, he is, because the nitrogen fixation is in the roots, and the root systems is where you're going to get most of your organic matter, not in the top. Okay, but keeping in mind, the farmer knows that when he takes a crop, a harvest, he's removing nutrient from the soil. So yes, he does have to make sure he keeps that balance. Yeah.
What is your experience using the little handheld pH meters that are out and available now? I'm a laboratory chemist from way back, and I don't necessarily trust. They seem too inexpensive to be accurate, yet the Lamont tests are not accurate either when you're just judging color.
Yeah. Well, they're...
It's easier in the garden itself.
Sure.
What's the most accurate way, barring sending these lab results in?
Well, there are some very expensive ones, handheld meters. As a matter of fact, I looked into buying one once. It's well over $200.
That's not expensive. But, I mean,
Well,
compared to what we're using in the lab.
okay. But they have meters that you can buy for $15 that have 2 prongs, and really all they're measuring is the conductivity. Okay. Let's go back to the very beginning of this seminar. Sampling procedures. You want to get a good representation of your area. How are you going to stick 2 probes in one spot and get a good representation of the whole area? You can't. If you want to do a pH test at home, the best thing to do is to, you can do a water pH test. You go to the drugstore and get pH litmus paper, and you get it in the range that you want it. And you just draw your soil samples the way you would draw them to take them to the lab. Take out a sample, mix it with distilled water, which you can buy at any grocery store, and stick the litmus paper in. That'll tell you water pH. And it's very accurate. The old farmers used to taste their soil because they said that you could actually taste whether it was sweet or not. And I suspect that there's something to what they said. I mean, I
did a lot of that as a kid.
Yeah. As a matter of fact, I tried it once. And I got to tell you, I didn't really get the sense that it was sweet. You know, I was like, God, get this out of my mouth, you know. But this farmer, if it's one of those things that's relative to what you're used to. If the farmer is used to a certain taste, whether it actually tastes like sugar or not, I really highly doubt it. But if they're used to a certain taste, and they can tell by touching the soil to their tongue if that taste is there or not, then they can actually tell if they need lime. Believe it or not. Any other questions? I like the fall because there's an awful lot of biological activity that goes through the whole season that can change things. So I like to do it in the fall. But whenever you do it, if you're going to test from year to year, you should do it the same time of the year. And you should do it at the same lab. You shouldn't switch labs around. You should make a decision on a lab and stick with them. Because if you switch labs, that's when you're going to get your most variance between tests.
Theoretically, if they're doing the same test, right?
Theoretically, yeah. Yeah. But a lot of people have done that. As a matter of fact, some of the gardening magazines will send out of one bucket of soil a sample to 5 different labs, and they'll show you how different those rates will vary. And the reason is really because of, possibly the way they're mixing their reagents or something like that, or the way equipment may be calibrated.
Thank you very much.
Thank you.
My pleasure.